Bismillahirrahmanirrahim. Welcome to a new lecture of discrete mathematics. So it's a continuous part of lecture number 12. So again, discrete probability and probability theory. So coming to another theorem, Bernoulli trial and the polynomial distribution. So an experiment with only two outcomes, either success or failure, is called Bernoulli theorem. It's just simply toss. When you are doing a toss in a cricket match, so you can be won, you can be lost. So when you are getting be won, you're getting be lost. So two outcome, yes and no, simple. So let P and Q be a probability of a success and a failure. P and Q be a probability of a success and failure. So it may be P can be success or failure, maybe Q can be success or failure, but respectively, then it follows that P plus Q is always equal to 1. P plus Q will always equal to 1. This is a formula. So Bernoulli trial are mutually independent. So Bernoulli trial are independent, not depend on anyone. Okay, so just keep in mind this thing, and then in an example you will better understand that how Bernoulli theorem works. Then theorem 2, the probability of exact k success. How many success? K success. I mean, it can be 1, 2, 3, 4, 5, 6. So how many success we have? K. So the probability of exactly k successes in an independent Bernoulli trial. Bernoulli trial means you are flipping your toss, you are flipping your dice. So it means number of your repetition. Simple. Trial means your repetition. With the probability of a success P, the probability of success P and the probability of failure Q. So according to this formula, Q is equal to 1 minus P. So from this formula we can get this one. So for a day that we have total number of independent Bernoulli trial, okay, and total, how many number can be successes. So K can represent it, and P is your probability of success. Okay, so using this formula, because you know that how we can solve. So using the combination concept, so C combination with the total number of independent trial and selection or chosen number of a success, then with the P raised to power k, that P raised to power k means probability of a k number, and Q is n minus k. So this is your formula. So how it will works, so we can see it, but just keep in mind combination of nk with the P raised to power k, Q raised to power n minus k. If we consider it as a function of a k, if we consider it as a function of a k, we call this function the binomial distribution. Again the same one, k in a function of a k, summation k start from 0 to n, and is your total number of a trial, k is your selection, and P then which is always equal to P plus Q raised to power n is equal to 1. So this is about binomial theorem or binomial distribution, and in a mathematics, hope you study it in school as well. There we had a binomial section which is in the form of this, and which is always equal to 1. Okay, so this is about binomial section. Now coming to a random variable. So a random variable is a function from the sample space of an experiment to the set of a real number. That is, a random variable assigns a real number to each possible outcome. It means what? We have a sample is like a universe, and from the universe you are taking some real things. So when a random variable is assigned, it means for random variable we are select we are giving a real number like 1 2 3 4 5 and so on, just like, and that will be our outcome. The distribution of a random variable x, distribution of random variable x on a sample space S. This is your sample space, okay, and we are distributing by random variable x, distributing by random variable x. On a simple space S is the set of pairs, where R and P probability x equal to R for all R belongs to x of S, where P of x equal to R is the probability that x takes the value R. A distribution, or mean real number, a distribution is usually described by specifying P of x from each of R belongs to S. So what does it mean now? So in this example, in this symbol you can study it now, that what does it mean, okay. So coming to the example, suppose that on a coin is a flip 3 times. Coin is flip 3 times. Let in a coin, in a coin we have head and tail. So let x of t be the random variable that equal the number of a head that appear when t is the outcome. Find f of t. Now let's see. Random variable, hope you guys know. Once you have a coin and you are flipping coin, you don't know what will happen. This is called random variable, okay, and we are assigning. So x of t we need to find. So when we are flipping, we have a head and we have a tail, head and tail, okay, make it clear. This is head and tail. So now you are flipping your coin 3 times. So if you are flipping your coin 3 times, so it can be head, then it can be head, then it can be head. So it's a possibility. So in 3 times when you are flipping your coin, so it's a probability that you have a head in 3 times. So head is a 3 times. So it can also be a possibility that we have a head 2 times and tail 1 time. It can be possibility that we have a head, tail, head. It can be possible that we have a head first, then we flip the coin again, it can be head, then we can flip a coin, it can be head. So head-headed, so the probability is like a 3, and in the xxt, xth and xtx like a thh. So what should be the probability here for the head now, just for a head? So because he is talking about head, so the probability is 2, okay. So it can also be possibility, we have also a possibility that we are flipping a coin. So first we have a tail, then we flip a coin, then we have a tail, then we flip a coin, maybe we can have a head, okay. So then again we are flipping a coin, we have a tail, then flip the coin, we have a head, then flip a coin, we have a tail. Then then again flip a coin, we have a head, flip a coin, tail, flip a coin, tail. So what should the possibility here? It can be, how many head we have? 1 now. In this kind of a section, like we have flipped the coin, we have a tail, flip the coin, we have a tail, flip the coin, we have a tail. So what should be the possibility of a head? 0 here, because 3 times we receive a tail is up here, okay. So according to this formula, now we can have a conclusion, because each of the 8 possible outcome, one thing you need to have in mind, to how many times we repeat it? 3 times. So how many possibility we have? 8. So because each of the 8 possible outcome has probability of 1/8, the distribution of xt is given by, like for p x is equal to 3, this one, p x is equal to 2, this one, p x is equal to 1, this one, and p x is equal to 0. 0 mean how many head we have? 3. How many head we have? 2. How many head we have? 1. How many head we have? 0. So the probability for p x equal to 3 is 1/8. how many time we have 1. Then probability of x is how many time we have 3, so 3 by 8. Then how many time we have this section, how many single one had is 3 by 8, 1 2 3 3 by 8. And how many possibility that we have to x is equal to 0 mean no sorry 1 over 8. So now this is, hope you guys understood this formula now here, that how we are going h is equal to or mean this is about your selection, your real number. We are talking here, we have a head, so and or belongs to all x of a space. Okay, so whenever somebody going to ask you that find out the probability of your head or tail, so once how many times you are going to flip your coin, so repeat that, then at the end you guys can easily find your probability. So you know about this one event, how many event we have here, 1, this is your event. And what was the space value, 8, so probability is 1, because you know about the formula now, that probability of an event means repetition of a and sample. And what was the sample, because 2 raised is 8, so just repeat it out and move on. So coming to Monte Carlo algorithm, so we have again some definition that deterministic algorithm always proceed in the same way whenever given the same inputs. Probabilistic algorithm make random choices at one or more step for its efficiency in a huge number of possible cases. So Monte Carlo algorithm said that the probability that the algorithm give the correct answer increases is more tests carried out. So it means once you are doing your testing and your correct answer is going to be increasing, so move on, do it again and again and have your correct answer. So coming to the probabilistic method, which was probabilistic method is used as existence proof to prove result about set as. Again the same example, again the same concept like a sample. If the probability that an element of set S does not have the particular property less than 1, there exists an element in S with this property. So this is just for your info that what kind of probability you have. Now coming to the Bayes theorem. So Bayes theorem says that the probability that a particular event occur on the basis of partial evidence. Keep in mind, on the partial evidence, for example, it is like conditional probability. Again the condition that here we can say that Hafiz will pass if he study hard. It's just like a conditional. So theorem can say that suppose that E and F are events from a sample space as such that probability of E and probability of F will not equal to 0. Okay, so the probability of F slash E, because it's based on conditional, so F will depend on E or E will depend on F. So P F slash E equal to P E slash F P F and P E slash F P F plus P E slash F complement and P of F. This is basically a formula. Okay, so again theorem 2 is the same like this. Suppose that E is an event from a sample space and that F1, F2, F3 and 4 up to Fn are mutually exclusive events such that I start from 0 to n and f of I is equal to S. Assume that P is not equal to 0 and Pf is not equal to 0 for I start from 1 to up to n. So this is a formula, just keep in mind. Same formula as a Pfj slash E. So Pe slash F Pfj divided by summation start from I to 0 to n P E slash F, then P F I. So this is your for this like a formula how we can use it. So this is the example from your book, so try to solve it out. Go to your books, take a help from there and solve it out. Then another some formula for expected value of a random variable. Random variable is a weighted average of the value of a random variable, provides central point for the distribution of value of the random variable. Again the same one, the expected value or expectation of a random variable f of x of s on the sample space s equal to, so e of x is equal to, like this is a formula, probability of s into x of a sample. Then theorem, if x is a random variable and p of x equal to r is the probability that x is equal to r, so that p x equal to r, the formula will be x is equal to this one. So it's all about formulas now. Then we have formula for a variance. Let x be a random variable on a sample space as the variance means changes, the variance of x denoted by v of x, which is in this form. And variance is like, if you can say about variance is just like a power which is in the form of a square. So the standard deviation of x is defined to be a sigma of x is equal to v of x. Once you are going to find out the standard deviation of a variance, so find a v of x, then put the v of x value into this one. This is your standard deviation. Standard deviation means whenever you have some changes your in your design, like you are designing a bridge, you are designing some in a building construction, so your standard deviation can be found by this one. Theorem 6. This theorem is mostly used in a probability. If x is a random variable on a sample space S, then v of x is equal to e x square minus, like this. So this have some differentiation. Just keep in mind e of x square minus e x whole square. Okay, so this example of all these definition you guys can be find it in your book. So go through your book and solve these questions, and that's your homework. So hope this will find you well. Watch it out. If you have any question, so raise your hand or a question, so I will try to answer it. Thank you for your time. See you in the next lecture.